Number 9. So we want to know what happens from -3 to 2 for f of -x. So this reflects across the x-axis. So in other words, if I plug -3 in here, I get -3 and plug in there, that's going to give me a +3 out. So when I plug in -3, that gives me +3 out, which is this thing. So what that does is it takes this -3 and reflects it over here to positive. I'm sorry, I lied. It's -3 0. So when I plug -3 in, yes, when I plug in -3, I get +3 out. So -3 is where the 3, this 3 becomes a -3 and comes back over here. It is -3 there, right? No, wait a minute. Where'd it go? Which number? 9. Oh, it's -1. So when I plug in -1, that value is -4. So when I plug in -1, it actually becomes +1, gives me out -4. So it takes this point and reflects it. Oops, I did the wrong one again. -1's at 2, -2. It reflects it to 1, -2. When I plug 0 in, that doesn't do anything, so it still stays at 0. Okay? And then when I plug positive 1 in, I get out 4, but when I plug +1 in, it reflects it to -1, so it's up here at 4. And then when I plug in plug in 2, that gives me actually -2, but +2 is a 4, so -2 is at a 4. So I have to get the area. Oh, if I can draw a straight line, I mean, that is so bad. Okay, so I got to get the area from the red to the X. From the red to the X from that picture. So this right here would be a trapezoid. That base is parallel to that base, and this is my height of 4. This base is 2, that base is 1. So I'm going to get 1 plus 2 times 4 all over 2 plus, I want this little triangle here, that's 1, this is 2. But it's underneath, so it's actually a -1/2 base times height. So let's see, those reduce to 2, so that's 6 minus 1, that should be an area of 5. Huh? It does reflect over the x-axis. So see, this 1 reflected, sorry, this 2 reflected over to here. This 1 reflected over to the, oh, did I say x-axis? It reflects across the y-axis. And then this point right here reflects over to there. That is -x, right? Where is it? All right, let me check this out again. So if I plug in -1, that is the same as f of 1. And f of 1 is 4. So when you plug in -1, you get out 4. Okay? So -1 gives me out 4. Oh, I did plug it in wrong, didn't I? Yeah, I don't know why I put that over there, because there's no -2 doesn't go in. So it's this triangle. I'm supposed to start at -1. So I plug -1 in and I get out 4. So that's my starting point. When I plug in 0, -0 is still 0, so it's still 0. So I still have this point. So I did put it in wrong. When I plug in f of 1, now I'm plugging in 1, but I'm going to get -1 out. So -1 gives me out -2, so that goes right there. And when I plug in f of 2, that is actually f of -2, 1, 2, which is -4. So when I plug in f of 2, I'm down here because it's actually the value at -2. So I should have had that red. So I did do that. I did not put that in there. So I'm supposed to reflect all these across the x-axis. So the area I want is actually this area. So this is wrong over here. So they're both triangles. So the first triangle is above, and it's 1/2 the base of 1 times the height of 4, and then the other one's below. So that's 1/2. And so it's minus because it's below. 1/2 base of 2, height of 4. So let's see, those 2's reduce, and that's, so we get 2 minus 4, should be negative 2. Is that what you said they had? Yeah, that's where it comes from. What else we got? Anything? 6.3b? Anybody?
The absolute value on page 219, right next to the x, that means that every value you plug in the positive value.
That's right. So here's what it means. Yes, these are the same thing. So in other words, if I do this, if I do f and I plug in -2, okay? That means I'm finding a value at 2 because the absolute value of that is 2. So at 2, the value is 4, right? So when you plug in -2, you are actually up here at 4. Okay? And then when you plug in the value of -1, that is actually the value of f of 1, which is also at 4. So -1 gives you positive 4 out also. F of 0 is still 0, so that's still down here. And then you plug in f of 1. Well, f of the absolute value of the 1 is still f of 1, so that's also a 4. How far are we going? Which one is this? This is this one, right? 18? So 18 wants the area of this. If I could draw better. So that is a trapezoid. And this one's a triangle. So it'd be base 1 is 1. Base 2 is 2. So it's 1 plus 2 times the height is 4 all over 2 plus that triangle. That triangle is 1/2. The base is 1. The height is 4. So let's see. This is going to be 6 plus 2. So that should be 8. Okay. Anybody else got one you want to see? 21. All right, so this goes back to transformations. Does anybody remember what +2, when a number's out there all by itself is added or subtracted, what kind of shift that does? Vertical shift. So this whole graph is moved up too. So what you could do is, you could do the long way and take every point and move it up 2 from where it is. Or there's a shortcut way. We could take this x-axis and say it's no longer here. And then we're going to move the x-axis down here. By moving that x-axis down to there, that means makes all these go up too. Does that make sense to you? So now this is 0. This one is 1. This is 2. This is 3, 4, 5, and 6. So if you look, it was 4 on the old one, but now it's 6 on this one. So you see it moved it up too by doing that? And we want to get this area from -1. So I want it from -1 over to 2. So that means I want this area right here. So that's the area I want. Now this is going to be 2 trapezoids. So I'm going to cut a line right there. Then I got a trapezoid on the bottom and a trapezoid on the top. So let's see, 1, 2, 3 is that base. This base is 2. And here's your height of 2. So the first trapezoid is 2 plus 3 times 2 all over 2. And then this trapezoid, this base is 2. This base up here is 1. And that height is 4. So the other one is 1 plus 2 times 4 all over 2. So let's see if we get 5 plus 6, 11. Okay? Anybody else got one you want to see?
+2, move the line down. 21, -3, move the line up.
No, but, oh, yes, you move your x-axis, yeah, move all the graph down. You want the graph to move down. So if you move the x-axis up 3 up to here, that moves the graph all down. If this is now 0, that's -1, that's 1, -2, -3, -4, -5, -6, -7. Yes, that is correct. Now, if you're going to draw on this picture, you got to use pencil because you're going to have to change it every time.
How would you do it with the chart? If you didn't have any graph at all? Could you do it?
Yeah, you could. I would make a graph probably with the chart. And then I would move the stuff around based on what it said. I don't think they're going to have a chart on one like this. Yeah.
Number 21, I don't know if you can figure out, but it's like a triangle, a trapezoid, and another trapezoid, but I don't.
All right, well, let's look at it. So this would be the graph, right? And I went from -2 to 1, so I'm starting here. Here's -2 right here. I'm going to go over here to 1, right?
It's -2. Number 21.
Oh, it is a 3. Okay. 1, 2, 3. So I'm going to here. So I really don't need this stuff out here. This does not matter out here. So here's the area that I'm looking for. There's the positive area. Now this is a hard problem because this graph is intersecting the x-axis, not at an integer.
So for that top trapezoid, what was that bottom parallel line? What's the value of it?
Okay, so we got that look right there. The red's negative, the purple's positive, right? Okay. So this purple part, we got to find out what this x value is to know what this length is. So this is a hard problem right here. Okay. So what I got to do is I got to get the equation of this line. So if I look at this slope is 1, 2, 3, 4 over 1. So my slope is 4. And I can pick any point I want on here, and I think I like 0, 0. Oh, that's not 0, 0 anymore. Let's take this point right here that is at 1, 1. So 1, 1 is on that point. Right 1, up 1. That point right there. You okay with that? So this graph is y minus 1 is going to equal 4 times x minus 1. That's that equation. The other equation where they intersect is where x equals 1, right? Because I want to get the intersection of this line with that line. So that's where x is 1. Nope. Yes, x isn't 1. Sorry, y is 0 there. Y is 0 right here where they intersect. So y equals 0. So I'm going to plug 0 in for that. And I'm going to solve that for x. So I add 4 over and I get 3. I get x equals 3/4. So this value right there at that point right there, that point right there is 3/4, 0. So that's kind of a hard problem because now, if I look at this, make this into trapezoid and because this is a parallel. So this base right here is 1, 2, and 3/4. So this is 2.75 right there. This one's 2, and that height is 3. You get the idea?
Yeah.
And then for this side, it's 1/4 plus 1 plus 1. This is 2.25. Is that one? That one's 2, and that height's 1 for that trapezoid. So that's a real hard problem. All right, let me spray, and I'll get that out of here, and I will see you tomorrow, or tomorrow on Zoom. Sorry, I just saw your thing. Wade, we'll have to do it when you come in tomorrow. Have a good one, guys.